So, hello everyone. I hope my voice is clear. So, am I audible to you?
Yes, ma'am.
Okay, my screen is visible to all of you.
Yes.
Okay, so I will be waiting for 5 minutes so that other people can also join. Then we will be starting this session. Okay, so just wait for 5 minutes. So, then we will be starting the session. So, I hope my voice is clear to you. Okay, so I hope you have seen the lectures, the week one lectures, which are uploaded on NPTL portal, the SWAM portal. So you have seen them. Okay, so okay, so we'll start the session now. So first, let me introduce myself. So my name is Himanshi Singh. I am currently a PhD scholar at Department of Mathematics, IIT Jodhpur, and I am pursuing my PhD in broad area of probability and statistics. Also, I'm your TA for the course Regression Analysis, which has been taught by, which is currently running on this SWAM portal, and it is Professor Soman Methi is taking it. So, today we will be, this is the first live session, first of all, and this is the live session schedule. So, this live session will be on every Monday from 6 to 8 p.m. So this is our first live session, and apart from this, these are the important links. So first one is the Google Meet link, which is the link for the for you to join the Google Meet. Second one is the YouTube channel link. So this is my channel where I will be uploading all the recordings. Okay, so you can access the recordings from here. Okay. Okay, and apart from this, the third one is the Google Drive link. So all the presentations and all the presentations will be available there in the on this folder which I have shared, the link which I have shared, and you can access this folder by this link. Okay, so this is our first live session, and for all live sessions, we have this plan. Like I will be first giving you a brief recap about the topics which are covered there in the lectures, and then we will be discussing some of the practice examples, which I want you also to do the examples with me, so that the class is little interactive. Then finally we can discuss the doubts. If you have any doubt or anything, then you will discuss it with me. So if any one of you have any doubt, then you may ask. Then we will be starting uh, the recap about the topics. So you can ask, or you can also uh, like send your message in the chat box if um, any doubt is there with you. Okay. So if there is no doubt, then I will be starting the session. I will be starting the topics which are covered. So basically, this course is the regression analysis, where basically we have some data and we want to approximate that data by a particular curve or a line, I can say. So in particular a line, but in general we can we have different kind of like models by which we can approximate that data. Okay, so basically, for example, let us take that I have some dependent variable x1, x2, k dependent variable, independent variables, and y is one independent depend. So this is a dependent variable, and these all are independent variables. Okay, so here the independent variables and dependent variable has some relationship. We do not know what that relationship is, what this function is, we do not know. So if this is a model, okay, and we want to determine the relationship between this independent variable and dependent variable. Okay, now if we want to determine that relationship, then what can be that relationship, how can we determine that relationship? So regression analysis is basically all about that. Okay, so here the behavior, so here this is the exact relationship, but that is not always true. There may be some errors occurred in the process or in the data, that we cannot get the exact fit. There may be some error, and that behavior is basically explained by this equation, where we are writing y is equals to some function of x1, x2, xk, and it may also, the relationship may also depend on some parameters, that is beta 1, beta 2, beta k, plus this epsilon is the random error. Okay, so this behavior is explained by this equation. Now we do not know the function f. Okay, so what this function f is. So basically, this is in broad the regression analysis, where we want to know or to determine the relationship between the dependent and the independent variables. Okay, now So basically here we have a model which we have discussed previously. Now that model can be linear, it can be non-linear. Okay, so we are today we will be focusing on linear model only. And okay, so the model can be linear and linear regression model. We are saying that linear regression model. So that basically means that that model is linear in parameters. So linear in parameter means the parameters which we have discussed like beta 1, beta 2, beta k. So it is linear in parameters. So how to find that whether this particular relationship or a particular model is a linear regression model or not. So I will be discussing it further after a certain after a certain discussion we will be discussing that. Okay. So first of all, in linear regression model, we have two types like simple linear regression model and multiple linear regression model. So we are in the first lecture, which in the first week lectures, we were basically focused on the simple linear regression model where we have one independent variable that is x. So this is independent variable and one dependent variable that is y. Okay, so there is only one independent variable, and apart from that we have two parameters, that is beta naught and beta 1, and this epsilon is the random error. So here this model is the simple linear regression model. Okay, now if apart from this simple x, so independent variable here is 1. Apart from that, if there are k independent variables, then that regression model will be multiple linear regression model. So that we will be discussing afterwards. But today, uh, we will be discussing or we will be focusing only on the simple linear regression model. Okay, so here this epsilon is basically the random error. Beta naught and beta 1 are the parameters which are also known as the regression coefficients. Okay, and also we have to assume or we will be assuming further for our calculations or the derivations that epsilon is independent and identically distributed random variable with mean 0 and constant variance sigma square. Okay, so basically we are saying that this epsilon is a random variable. Okay, and so basically if I have observations like y1 y2 yn and x1 x2 xn, then for each xi yi there is an error epsilon I, so that is epsilon 1 epsilon 2 till epsilon n. Here this epsilon basically is a random variable whose mean is 0 and variance is sigma square. So basically the expected value of epsilon is 0 and the variance of epsilon is sigma square. Okay, so this is basically the assumption. Now, here we do not know what beta naught and beta 1 are, so we want to estimate them. Okay, so this is the method for estimating that is the ordinary least square estimators of beta naught and beta 1. How do we estimate them? So basically, we will be minimizing the square of the errors. Okay, so sum of the squares of the errors. So basically, if I have the observation y1, y2 till yn, okay, and I have the model yi is equals to beta naught plus beta 1 xi. Okay, now I do not know what beta naught and beta 1 are. So basically what I will be doing, I will be subtracting. So for example, I will so this is the so this yi, so I will be subtracting. So this is a yi hat kind of thing. So yi minus this thing beta naught minus beta 1 xi whole square summation. I will be minimizing that. So so this is a function of beta naught and beta 1. I know the yi's, I know the xi's. Okay, so I will be minimizing this expression with respect to beta naught and beta 1 in order to get the estimators for beta naught and beta 1. Okay, so by doing that process, we got the estimators of beta naught and beta 1 to be beta naught hat is y bar minus beta 1 hat x bar, and beta 1 hat is sxy divided by sxx, where sxy and sxx is this, and x bar and y bar are the just the average of yi's and xi's. Okay, so basically I have a data x1 till xn, I have a data y1 till yn. I can find all these values. I can find y bar, I can find x bar, I can find these terms, I can find this term. And I will just put the values here and I'll get the estimates of beta naught and beta 1. Okay, so basically by that I will get the equation of the line to be y to be equals to beta naught hat plus beta 1 hat x. So that will be, so whatever the estimates are, I will put it here, and that will be our regression line which will fit the data. With, so basically the idea was to minimize this the square of sum of the square of the error. Okay, so that was the idea in order to estimate the parameters beta naught and beta 1. Further, I also have this term called residual. So, for example, yi is the observed value. Okay, yi hat will be the fitted value which I have fitted using this beta naught hat and beta 1 hat. Okay, so this is nothing but beta naught hat plus beta 1 hat xi. Okay, now this difference yi minus yi hat. So, this difference is called residual. Okay, so this will be the ith residual. Okay, and if I sum that for also, if I find out the sum of this yi minus yi hat square, so this we call it as residual sum of square, which is represented by ssres. This quantity is very useful, so we will be seeing further that this quantity is used many times. Okay, so this is yi minus yi hat square, so whole square sum of this, so this is called as residual sum of squares. Okay, and this ei, this is a quantity yi minus yi hat, this ei is called the ith residual. And we've also learned in the class that summation of ei is 0. By the derivations it was proved that summation of ei is 0. So here, and this ssres is the summation of ei square. Okay, so this quantity is this. Apart from this, we have also seen, so we have found out these estimators beta naught hat and beta 1 hat. So now what are the properties of these estimators? So basically both the estimators are unbiased estimators of beta naught. So this is unbiased estimator of beta naught, this is unbiased estimator of beta 1. So basically expected value of beta naught is beta naught hat is beta naught, and expected value of beta 1 hat is beta 1. Okay, also if I find out, so this uh, basically when these are the estimators, I know they are unbiased estimators, then what are the variances of beta naught hat and beta 1 hat? So the expressions for the variance of beta 1 hat and beta naught hat are this, and here we can see there is the expression sigma square, and this sigma square is not known. We do not know what sigma square is. Okay, so in order to estimate the sigma square, this quantity, this is msres, that is residual mean square, which is nothing but ssres divided by n minus 2. So this is an unbiased estimator of sigma square. So in practice, we do not know sigma square. So if we want to find out the variance of beta 1 hat, we cannot find out directly, but we can find out its estimate by replacing the estimate of sigma square here. So if I write here msres, then that will be the estimate of variance of beta 1 hat. So that is there in the next expression. So if I want to find out the estimate of beta 1 variance of beta 1 hat, so that will be, in place of sigma square, I'll just write msres. So that is an unbiased estimator of sigma square. That's why I've replaced sigma square with msres here, and this will be the estimate of variance of beta 1 hat. Similarly, the estimate of variance of beta naught hat is this. And also we had expression for the covariance. So here also we have sigma square, and here we have replaced this with this expression msres. And also we have discussed that the ssres divided by sigma square. So this basically is a chi-square random variable with n minus 2 degrees of freedom. Okay, and we know that ssres is nothing but n minus 2 msres. So we can also say that n minus 2 msres divided by sigma square is a chi-square random variable with n minus 2 degrees of freedom. So just we have replaced the ssres with n minus 2 msres. Okay, so apart from this, so this was all about the ordinary least square estimators. That the estimate, what are the estimators, whether they are unbiased or not, and what are their variances.
एक्सक्यूज मी मैम।
Yes.
मैम जिस तरीके से आप ट्यूशन समझा रहे हो समझ नहीं आ रहा, थोड़ा धीरे और हिंदी में बता सकते हो?
Hindi mein, but this course is not in Hindi, na. That's why I'm, because some students may not like understand Hindi.
Yes, madam. Actually, this is in a English medium
Yeah. So
course.
yeah,
That-
that's why I cannot. Uh,
Because we are in south side, okay, we don't know Hindi. Therefore, you better to speak in English because the medium of instruction is in English.
yeah, that's why I'm like teaching everything in English, because this course is not in Hindi. Okay, so if there is something which you cannot understand, then you can ask. I will explain that. Actually, I'm going a little fast because all these things are already taught in the course, actually. That's why I'm just recalling them. So, is there any doubt? Is there any doubt?
No, madam, you can continue, madam.
Okay. Okay, fine. So here we have discussed these things. Now, apart from this, in order to check whether there is a relationship, linear relationship with the, so we have this model y is equals to beta naught plus beta one x. Okay, so this is the line we have fixed. So whether the data, so for example, I have observation y1, y2 till yn, x1, x2 till xn, and I want to check that whether they are linearly related or not, whether there is such kind of relationship between them or not. So in order to check that, the method of testing of hypothesis was also discussed. Okay, so if I want to check that whether there is a linear relationship or not, I will just check that whether beta 1 is 0 or not. So if beta 1 is 0, that implies there is no linear relationship. Okay, and if beta 1 is not 0, means there is a linear relationship. So that's why we will be testing that hypothesis only. So here in the hypothesis, we are giving the hypothesis like beta 1 is equals to 0 in the null, so which basically implies that there is no linear relationship, versus the alternative, that is beta 1 is not equals to 0, that is there is a linear relationship. Okay, now when we reject this the null hypothesis, so there are two cases whenever the sigma square is known. If sigma, we know the sigma square, so in the question it is given that sigma square is known, then what we will be doing, we will be finding this expression, that is beta 1 hat, which I've already discussed, that beta 1 hat, the expression for beta 1 hat, here it was there. So beta 1 hat is this sxy divided by sxx. So you can find this expression. So beta 1 hat divided by under root of sigma square divided by sxx. So everything you know, you just evaluate this quantity, find out the modulus of that quantity, and just compare it with z alpha by 2. So if that is greater than z alpha by 2, then we'll reject h naught, otherwise we will not reject h naught. H naught means this null hypothesis. And if sigma square is not known, then our statistics will be this. So this we will be calculating. Here we have beta 1 at same, but here in place of sigma square, we have MSRES. So you can also calculate MSRES. We also have the expression for MSRES. So that is, so MSRES was SSRES divided by n minus 2. So this is the expression. You can calculate this also, and then you can calculate the whole statistics. Then you can find out the modulus and then see that whether that quantity is greater than T alpha by 2 comma n minus 2 or not. So this is basically, these quantities you can calculate using the tables. So here you can, the standard normal table you can check in order to find z alpha by 2, and here the t table. Yeah, recorded video will be available on YouTube. The channel link I have provided. So by tomorrow it will be uploaded on YouTube, and you can access that. Okay, so now just tell me that how many of you know how to find out this z alpha by 2 or t alpha by 2. So should I tell you, or you know all this thing to find out the values? So if people know how to find out these values, so I've provided the link here in the slides. So see here, this is the, so I will be like, I'll just text this link in the chat box, the link for the YouTube channel, and also the link for the Google Drive link. So you can just access it from there. So I've provided the link in the chat box for the YouTube link and also the Google Drive link. So from there you can access the material. Now just tell me that you know the if you know the value, how to find out the value of z alpha by 2 t alpha by 2, then I will not be taking that. If you do not know, then just tell me. I will be explaining you that how to find out these values.
Yes, madam, we know that. How to
Okay.
find normal table and T table. Yes,
Yeah.
we know.
Okay, fine. So then I will be discussing this in the example when we will be discuss that and you can see. Okay. So we will be starting the questions then. Okay. So if there is any doubt, then you may ask. Otherwise, we will be starting the questions, the practice
Madam,
question.
right? Sum of EI is always 0.
Yeah.
Okay. In case beta naught is 0, what happens?
In case
Sum,
beta naught is zero.
yes. Any conditions is there. Actually, sum of EI equal to 0.
Yeah.
Provided beta naught is occurring or beta naught 0 means what happens? Then also it is sum of EI is 0.
So EI is basically what? So EI is yi minus yi hat.
Yes.
Okay. So whenever we are summing it, so so if beta naught is zero, so that condition was coming from the differentiation. So whenever we were differentiating with respect to beta naught, then it was the condition was coming that summation ei is zero. Now if beta naught is zero, I don't know that whether we can say that or not, because
No, I
because
want to know about beta 1. And as you have said that if beta 1 is 0, the relationship is not linear. Then what are the other possibilities of the relationship?
yeah, the
Would
relation.
it be quadratic, curvilinear? What kind of relationship it
So
would be?
here the quadratic and all those things are related whenever there is a power of xi. Actually, here the x is simple x. There is not no we are not fitting a polynomial to the data. Okay. Now here I'm saying the relationship is linear means that the we will get a line if beta naught and beta one is there. So if the beta one is zero, okay. So the relationship is not linear. So for example,
Okay,
so
okay.
like y is equals to, for example, beta naught plus beta one x. So here if beta one is zero, so y is equals to beta naught. So we
Yeah,
can
it will.
I cannot say that y
Okay.
and x are linearly related.
Yeah, beta 1x will become 0.
Yeah.
Understood.
Madam, in case y is equal to beta naught, it is also line equation only.
No, it is a point, just a constant. It is not like y is equals to beta naught. So here
Yes,
there are
we
no two
are
variables. So
y is 2. Okay, it's a line only. It is
no,
not a point.
so it
I
is a
want to
y.
know the difference because y is equal to 2 or y is equal to 3. If I am saying that it is a
Yes,
line passing through y is 2 or y is 3.
It would be straight vertical line then.
yeah, it will be a straight vertical line. There is no role of dependent or independent variable. There is no
Horizontal.
role of the data to it. So basically, our motivation is that I have a data. One is a dependent variable, one is an independent variable, and I want to see that what are the relationship between these two variables. If y is equals to beta naught, there is a no role of a second variable.
That is okay, madam, but we can't say that this is also linear only. Y is equal to beta naught also linear only. That's why my question.
So y is equals to beta naught is linear in what sense?
Y
If I'm
is
saying,
equal, y
if
is
I'm
equal to 2. It's again a line equation. We
yeah,
can
it is
call that also linear equation.
you are not getting what I'm saying. Our main goal is to do the things with two variables. If there are two variables and I want to fit a linear line to the data, and if there is a no role of the second variable, y is equals to beta naught, it is just a straight line. What is the
Yes.
role of the data to it? So you are saying y is equals to beta naught. It is fixed. It is fixed. There is no role of the data. There the y is not even a random variable in that scenario.
Okay, madam.
Okay, because we are in the motivation only we are considering that y is a random variable which may vary. And if you are saying y is equals to beta naught may be a fixed quantity, y is equals to 2, it is a line. No doubt it is a line, but what we are studying is the main focus of concern.
Now I understood, madam. That's why I'm asking this question. Thank you.
Okay. So anything else?
And my previous question, madam, sum of EI is 0. What happens if beta naught is 0? It is true for that case also.
Yes, yeah.
So if beta naught is
ले
0,
आया सब कुछ मैंने पढ़ी के मुझे बल्ब भी मिल गई
so you are saying, so this y
लिंक
is
भी मिल गई
beta 1, so the
विद
real,
द लिंक मैम वो मिल गई
so someone is
दे
unmute.
देना साथ
Please mute your mic.
या
Please
आप
mute yourself.
जूस से जो हरे रंग की होती है वो मिल गई लड्डू आधा किलो लाया हूँ
Hitesh, please mute yourself.
इसलिए लेके जाने या पाइया ले जाओ उसके अंदर जो है ना कि पाइया मिल केक आ जाएगा
Hitesh, please mute yourself.
आई एम सॉरी मैम
Okay, so y is equals to beta 1x. Okay, so there what we have done, we have two parameters, beta naught and beta 1. We have differentiated with respect to beta naught, then we got the condition that summation of yi minus yi hat is equals to 0. Okay, so here the summation of yi minus yi hat will be what? Summation of yi minus beta 1 xi. Okay, now here if you differentiate with respect to beta 1, there is no beta naught, then we cannot say that summation of ei is 0. I don't think so.
That's why I have a doubt in this place. That's why I'm asking.
Yeah. Okay, so for this you can also do one thing, like just take an example, okay, and just consider this model, take an example and just see whether, because here what is the thing is, like we are considering basically this kind of a line or this kind of a line where there is no intercept term. Okay, so we cannot say that summation of ei is 0 in that case, I think.
That's why I'm asking. I have a doubt on that. That's why I'm asking. Thank you.
Okay, so anything else? If there is something, then we can discuss. Otherwise, we'll start with the questions. Okay, so here I have taken some of the examples or some of the questions where it is asked that we have to find out that whether the models are linear regression model or not. So basically in linear regression model, if I am saying that it is a linear regression model, so basically we are saying that it is linear in parameters. Okay, it doesn't mean that it is linear in x. So I'm saying a linear regression model. Here I'm not talking about simple linear regression model. Here I'm talking about in general a linear regression model. Okay. So for example, I have y is equals to some f of x1, x2, xk. In general, I'm talking here about. So here if I'm talking that this is a linear regression model, and here also we have parameters like beta 1, beta 2, beta k, then I'm saying the linearity means it is linear in parameters beta i's. Okay, so here if I talk about that, identify whether the models are a linear regression model or not, so I will just see that whether that model is linear in beta i's or not. And how do we check that whether this model is linear in beta i's or not? So here I can see that y is equals to beta naught plus beta 1 sine x plus epsilon. Here I have beta naught and beta 1 as parameters. Okay, so whether they are linear in beta naught or beta 1 or not, so I'll just differentiate this with respect to beta naught. Okay, and I'll differentiate it with respect to beta 1, and I'll just see that whether the result and here whatever I'm getting, they are independent of beta naught and beta 1 or not. Okay, if they are independent of beta naught and beta 1, both of them, then I can say that the model is a linear regression model. Otherwise, I cannot say that the model is a linear regression model. Okay, so here if I find out that the differentiation with respect to beta naught, so it will be 1, because here this is independent of beta naught, so it will be 0. Only this will be the differentiable with respect to beta naught, and it will be 1. Okay, and if I find out the partial derivative with respect to beta 1, then it will be sine x. Both are independent of beta naught and beta 1. Okay, so both are independent of beta naught and beta 1. Only two parameters were there. So this implies it is a linear regression model.
Madam, can we say the parameter degree is 1 means we can say that automatically it is a linear regression?
So for example, if I say, so I will get to it. So for example, if in place of this, if I have a thing like e to the power beta 1x, then what will we say? So beta naught plus e to the power beta 1x plus epsilon, then what you will be saying? Is it a linear regression model?
Okay, madam. Okay, then we have to verify this condition. Okay, thank you.
So we have this kind of example further. So just tell me the second one, that whether it is a linear regression model or not.
A second one is linear regression.
Yeah, because if we differentiate with respect to beta naught, it will be 1. With respect to beta naught, with respect to beta 1, it will be x, and with respect to beta naught, it will be x square. And all the three are independent of beta naught, beta 1, beta 2. So that's why it is a linear regression model. So anyone have any doubt in this? Okay, now third one.
Non-linear regression.
So it is not linear, because with respect to beta naught, if I do the differentiation, it is 1. But if with respect to beta 1, if I do, so it is 2 times beta 1 x. So it is del y over del beta naught, and it is del y over del beta 1. So it is dependent on beta 1, so it is not linear. So here you can see that this is not linear. However, the x is in single power, but it is not linear because here the parameter is not in single power. We are getting the differentiation dependent on beta 1. Here, this is the example, the fourth one, that if we, so here you can see that both are in single power, beta naught and beta 1. And here if I differentiate it with respect to beta naught, it is 1. But if I differentiate it with respect to beta 1, so here what I will be getting, so it is x e to the power beta 1x. So it is dependent on beta 1. So it is not linear. Is it okay? Any doubt? If someone has any doubt, then please just stop me and ask. Is there any doubt?
No, madam. And the next one also non-linear. Correct.
Yeah, so next one, if I find out, so if this del y over del beta naught, so it is 1. But if I find out the del y over del beta 1, so it will be beta 1x, and the differentiation of this with respect to beta 1 will be x, so it will be 1 by beta 1, and it is dependent on parameters, so it is also not a linear regression model. So is it okay? Is this kind of questions are okay? So if there's some question like this appear to you, then you must be able to figure out. Okay, so now let's move for the next question, and please answer the questions in the chat box at least, so that I can have an idea that whether you people are understanding or not. Okay, so I'm moving for the next question. So this says that for a fitted model, y is equals to 4 plus 5x, what is the rate of change in average value of y? So what can we say about that? What is the rate of change in average value of y? So in statistics, if I say about the average value, so average value is kind of an expected value of y. Okay. So I want to know that what is the rate of change in average value of y with respect to x. So if I change the x, then at what rate y will change?
So 5.
Yeah. So if I increase x by 1, the y will be increasing by 5. So in mathematical terms, if I want to write in a more precise way, so first of all, I want to find out the average value of y. So that will be the expected value of y. So in assumptions, we have considered that y is a random variable, x is not a random variable, x we can control the value of x. X is not a random variable. So in the right hand side, if I apply the expectation, so 4 is constant, 5 is constant, and x is not a random variable. So expectation of y will be as it is, 4 plus 5x. Now I want to find out the rate of change with respect to y. So the rate of change, so the expectation of y dy, sorry, dx, with respect to x I want to check it, so it will be 5. So the rate of change with respect to x, the average value of y is 5. So basically I want to say that if I change x by 1 unit, y will be, or I can say increase, not change, increase. There will be a more precise term to write. So if I increase x by 1 unit, y will be increased by 5 units. Okay. So is it okay? So this basically is the interpretation. If I fit a, like I have a fitted line, so what is basically the interpretation? So this is nothing but the value of beta 1. Okay. So that is basically the slope of the line. So is it fine? The interpretation is fine?
Yes, madam. Nice explanation, madam. Thank you.
Okay, so if in the so similar kind of question, one more question. So if I have a fitted model, y is equals to 10 minus 3x. Okay, so now what is the change in average value of y if I increase the x by 1 unit? Now here you can see that here we have a minus sign. Okay, so basically, first of all, so I am writing all these things mathematically in order to tell you that I am talking about the average value of y. On an average, what will be the scenario? Okay, so expected value of y will be 10 minus 3x. Here I'm not considering x as a random variable, that's why it will be same. Now what will be the change? So the derivative of this with respect to x will be minus 3. So basically it is decreasing. So whenever, so basically it says that if I increase the value of x, the value of the average value of y will be decreased. Okay, so here it will be decreased by 3 units because I am getting the rate of change to be negative of 3. So when x is increased by 1 unit, so here I can say if x is increased by 1 unit, then y will be decreased by 3 units, or I can say average value of y. Okay, because here the y is a random variable, I cannot say the value of y. Because y is a random variable, the average value of y will be some quantity. Okay, so here the average value of y will be decreased by 3 units. So is this fine with all of you?
Yes, madam.
Okay, fine. Then we have also learned the concept of residuals. Okay, so this question is on that only. So I have a fitted model. Okay, so that fitted model is y is equals to 12 minus 13x. Okay, now one of the pair of observation used for fitting is x is equals to 3, y is equals to minus 17. So this is one of the observations. So for some I, xi is 3 and yi is minus 17. So this is some observation. So let us say that xi is 3 and corresponding to that yi is minus 17. So 17. So these are observations. Okay. Now calculate the residual corresponding to x is equals to 3. I want to calculate the residual. Now what the residual is? So residual, we have studied that residual ei is equals to yi minus yi hat. And here yi is the observed value and yi hat is the fitted value. So I know for xi is equals to 3, yi is minus 17. So this is the observed value. So first of all, I have to find out that what is the fitted value. So what is the fitted value? So for xi is equals to 3, I know the equation which I got, the fitted line I got. So the y I hat will be 12 minus 13 into 3. So this will be the fitted value. Okay. So what will be the fitted value? 12 minus 39. So that will be, so what will be 917. So is it fine? Y I hat is fine?
Minus 27.
Okay, yeah. Minus 27. Yeah, you are right. So it will be minus 27, sorry. So this will be the yi hat. So this yi hat is the fitted value and yi is the observed value. So observed value was minus 17. So what will be the residual for it? So residual will be minus 17 minus of 27. So that will be plus of 27. So it is 10. So is it fine?
Residual is E square or EI value?
No, sir, the residual is EI. Okay, so what this EI square is the square of the residual and summation of EI square is the residual sum of squares. Here I'm
Okay, madam.
talking about the residual. Residual means that what is basically the difference between the observed value and the fitted value.
That's error.
Okay, so here that's why in order to make you comfortable with the terminology, I have taken this example because you know that what basically the residual sum of square, that is fine. But here I want to take this example in order to tell you that what we see at a particular observation what we are doing, and then finally we will find out the sum of ei. So that will be 0 in this case, and sum of ei square will be some quantity. So that we will be doing in the next examples. Okay, so I think this is fine. This question is fine. We'll move for the next question. And I want in the next question, please cooperate with the calculation. Okay. Then the class will be a little interactive also. It will not be that boring. Okay. So yeah, so this question is consider this following observation. So I have this dependent variable y, independent variable x. Here, these are the observations. Okay. Now give the equation of the line to be fitted in the given data using the method of least square estimation. So we all know that what are the estimators. So like I want to fit a line y is equals to beta naught plus beta 1 x. Okay, and I want to find out the beta naught hat and beta 1 hat. I already know the expressions for beta naught hat and beta 1 hat. So what are those expressions? So beta hat. So it is sxy divided by sxx, and it is y bar minus
Y bar minus beta 1 cap into
x bar.
bar.
Yeah. So basically, I want to know this quantities, this sxx, sxy, y bar, x bar. So let us write this data first of all. So here, if I write, so let me first erase it because I'll use the whole page for it. Okay, so here I have x, y, xi minus x bar, yi minus y bar, xi minus x bar into yi minus y bar, xi minus x bar whole square, and yi minus y bar whole square. So I'll find all these quantities. Okay. So what is the data? 1 till 7. Okay. So first of all, let's find the sum of these quantities. So what will be the summation of xi will be what? Just tell me. What will be the summation of xi's? Twenty-eight. Yes. And summation of yi's? Yes, 28 is correct. So summation of xi is 28. What will be the summation of yi?
58.
58. Now from these two quantities I can find out x bar and y bar. So what will be the x bar? So x bar is 28 by 7. Okay. And y bar is 58 by 7. Yeah. So x bar is 4 and y bar is 8.28. Okay. Now we'll use these quantities in order to further find out these values. So just tell me. So now here x1 is 1 and x bar is 4. So 1 minus 4 it will be minus 3. 2 minus 4 it will be minus 2. 3 minus 4 minus 1. 4 minus 4 it will be 0. 5 minus 4 it will be 1. 6 minus 4 it will be 2. 7 minus 4 it will be 3. So this is xi minus x bar. Yeah. And what will be the y bar, yi minus y bar? So the y bar is 8.28. So 13 minus 8.28. So it will be
4.72.
yeah 4.7. Now 12 minus 8.28 it will be 3.72. 10 minus 8.28 it will be 1.72. 8 minus 8.28 it will be minus of 0.28. 7 minus 8.28. 7 minus 8.28 it will be
1.28. 7 minus 8.28 minus 1.28.
minus 1.28. 5 minus 8.28 will be minus of
Point
3.28.
minus 5.28. Next one.
Minus 5.28. Now I have to product them in order to find out this product. So it will be 4.72 multiplied by 3. So what it will be?
Minus 14.16.
Yeah, minus 14.16. Next one. Minus of
Minus 7.44.
yes 7.44.
Minus 1.72.
1.72. This will be
0.
0.
minus 1.28,
28. This one
6.56 minus 6.56,
and this will be minus of
minus 15.84.
15.84. Yes. Now we will be squaring it. So squaring this quantity. So xi minus x bar whole square. So it will be 9. This will be 4. This will be 1. This will be 0. Okay. So I'll be writing this in the next page. So here I'll write xi minus x bar whole square. Yeah, xi minus x bar whole square. Here I will be writing because it is not allowing me to write on that page. So yeah, so it is xi minus x bar is minus 3, so it will be 9. It is 4. Then after that, it is 1. Then 0, 1, 4, 9. Is it correct?
Yes, madam, correct.
Okay. Now yi minus y bar whole square. So yi minus y bar for the first observation it is 4.72 whole square. So what it will be?
7.40.
No, 4.72 whole square.
Sorry. 4 point
4.72 whole square. So this is y minus y bar. So that is 4.72. So this whole square.
22.2.
So the next one is 3.72 whole square.
13.84. 13.84.
Yes. Next one is 1.72 whole square.
2.96.
2.96. Next one is 0.28 whole square.
0.28 whole square, 0.08.
0.08. One more decimal, 0.08. Fine. And next one is 1.28 whole square.
1.64.
And next one is 3.28 whole square.
3.10.76.
28 whole square. 3.28. And the next one is 5.28 square.
5.28 whole square, 27.88.
Okay. Now we have to find the sum. So we have to find out this first of all, summation of xi minus x bar multiplied by yi minus y bar. So sum this. So what will be the sum of this quantity? Sxy.
Madam, xi minus x bar into yi minus y bar whose sum is minus 47.
Minus 47. So here we have Sxy. We basically write it in this way: xi minus x bar whole multiplied by yi minus y bar. So this quantity is coming out to be minus 47. Okay.
Yes.
Now what will be the summation of xi minus x bar whole square? This thing. So that will be SXX.
28.
28. Okay. And what will be this summation of yi minus y bar whole square?
79.43.
79.4. Okay. So, so we basically got all the quantities. So let me write it. SYI 79.4. Now what we have to find out beta naught hat and beta 1 hat. So what is beta naught hat? So that is y bar.
Y bar minus beta 1 hat X bar.
And what is beta 1 hat? So this is S.
SXY divided by SXX.
Yes. So what is SXY? SXY is minus 47. It is minus of 47 divided by what is SXX? That is 28. 28. So what will be this beta 1 hat? Minus of
Minus of 1.68.
1.68. Yes. And what will be beta naught hat? So y bar was 8.28 minus beta 1 hat is negative. So this will be positive of 1.68 multiplied by x bar was 4. What will be this?
15. 1 5.
So beta
15.
naught is 15. Beta 1 hat is minus 1.68 and beta naught hat is 15. Okay, so what will be the equation? So y is equals to 15 minus 1.68x. So here this kind of equation is like I have an intercept term, like when x is 0, y is 15. So for example, if 15 is here, so y is 15. So from here, and the slope is negative. Here I have this negative. So this some kind of this kind of a line. So this is not the exact line. This kind of a line we have. Okay, so this is basically the fixed fitted line. Okay, so in the question it was asked that I have to give equation of the line which is basically fitted into the data. So this is the first part. Now in the second part, find the fitted values of y for x is equals to 3 and x is equals to 5. Now for x is equals to 3, the observed value of y was 10. For x is equals to 5, the observed value of y was 7. But what will be the fitted value? So if I want to find the fitted value, I'll just put the observed value of x into this line. Okay, so for x is equals to 3, the the fitted value of y is, so it will be what, y is equals to 15 minus 1.68 and we will be multiplying this by 3. So what will be this value?
9.96.
9.96. Similarly, if I want to do it for x is equals to 5, so here for x is equals to 5, the fitted value of y is equals to 15 minus 1.68 multiplied by 5. So what will be this value?
0.6.
What? 6.6.
6.
Okay. So these are the, so I can see here 9.96 is the fitted value of y when x is 3, and what was the observed value? 10 was the observed value. Okay, so 10 was the observed value and 9 points. So there is a little error, or I can say the residual is the difference. So here 9.96 and 10 was the observed value. And for x is equals to 5, the observed value was 7 and the fitted value is coming out to be 6.6. So there is error. So this is the fitted value. So this is basically the y I had, and the observed value was 6 or 7, I can say. Yeah, 7 for x is equals to 5. So this is the difference between the fitted value and the observed value. In the next question is asked, what is the residual sum of squares? Okay, so residual sum of square is what? So that is basically sum of ei square. I going from 1 to n. Or what is n here? How many observations we have? 1, 2, 3, 4, 5, 6, 7. 7. 7 observations we have. So it is 7. If I want to find out, so there are two ways to find out. First way is like I just find out why I had for each observation, find out the difference, square them, and sum. One way is this. Other way, in the derivations wherever we were doing, we got an expression that summation of ei square is equals to. So in the derivation we got this. Just give me a minute. So the expression was summation of yi minus yi hat square. So that was equals to. So this was coming out to be syy minus beta 1 hat square sxx. Okay, so I can, so there are two ways to calculate. One way is to calculate yi hat for each of the observation, find out the difference, square them, and then sum them. Okay. Other ways, as we have already found out beta 1 hat square, we have found out xxx, syy also we have found out. So just put the expressions or put the values here and just find out the values of summation ei square. Okay, so I'll just use the second method where I will be just putting the value of syy, sxx, and beta 1 hat square. Okay, so that will be what? So syy is 79.43. So it is 79.43 minus beta 1 hat was 1.68. So it is 1.68 whole square, and sxx is 28. So it is 28. So what will be this? Value?
0.40.
0.40. This is the residual sum of square. So is this fine? Okay. So is this fine? Is this question fine? Is and there is any, if there is any doubt, then please ask. So what we have done, we have fitted a line. Okay, we have found out the fitted values for some observations for x is equal to 3 and x is equal to 5. Then finally we have found out the residual sum of square, that is SSRES. I can say SSRES. Okay. Okay, then if there is no doubt, then we'll move for the next question.
Okay, madam.
Okay, so again we have the following observations for dependent and independent variable. Okay, now in the question it is asked that suppose that we want to test whether or not there is a linear association between the variables or not. Okay, we know that y is a dependent variable, x is an independent variable. Okay, and we want to know that is there any linear association between the variables, and in the we are basically assuming that we can fit this line beta naught plus beta 1 x to it. I want to know that whether there is a linear relationship or linear association between this y and x or not. So basically, I test the hypothesis that beta 1 is equals to 0 or beta 1 is not equals to 0. Okay, so basically, what will be the hypothesis for it? So the null hypothesis will be that beta 1 is equals to 0 versus the alternative will be that beta 1 is not 0. Okay, so beta 1 is 0 means there is no linear association, and it is not 0 means there is a linear association. Okay, so for that, we have to find out the test statistics first. We want to compare that. So here you can see that in the question there is no information about the sigma square. So basically, we do not know the sigma square. So we have to find out the value of the test statistics. That was t statistics. That was ultimately the distribution of that statistics was the student t distribution. So the statistics was t is equals to beta 1 hat divided by square root of MSRES divided by SXX. So here the MSRES was SSRES divided by n minus 2, and SSRES is what? Sum of that is summation of EI.
Yes,
Okay, which we have already in the previous expression we have calculated. So for that we need SYY
madam,
minus.
in a test, you write the formula first, that is beta 1 hat minus beta 1. Next line, you say that beta 1 is, we assume
So
0.
this is the
Similarly,
test statistics which is under the null hypothesis only.
most of them not understand minus beta 1 is there.
So that was the test statistics. So here I am considering under the null only.
Yes, madam. Actually, beta 1 hat minus beta 1. Beta 1 is 0. Here, yes, that's why it is become beta 1 hat divided by square root of ms. Yes, that will comes.
So actually I have directly written under the null. Okay, fine. So here under the null if I want to write it, because under the null hypothesis it is 0. So that's why it will be, so beta 1 is not always 0. That's why I am not, okay, fine. Here I should
This
mention.
is a test statistics formula.
So this is the test statistics, but under the null T is beta 1 hat divided by under root of MSRES divided by SXX. Okay, because under the null beta 1 is 0, and whenever we are testing a hypothesis, we will test it under the null. Whenever we are finding out the test statistics and want to test it, then we will be testing it under the null hypothesis only. So it will be beta 1 hat divided by this quantity. Now here I have to find MSRES. So that is nothing but SSRES divided by n minus 2. And what is SSRES? So that is summation of EI square. So that we have previously also we have calculated. So what was the formula for it? So this is S Y
YY
Y.
minus beta 1 hat whole square SSX. SSXX.
Okay. So this is the formula for SSRES. So for that we also have to calculate all these things. We have to calculate beta 1 hat also, and beta 1 hat is nothing but SXY divided by SXX. So we have to calculate SXY, we have to calculate SXX and SYY for the data. So let me calculate that first. So if I write X here, Y here, Xi minus X bar, Yi minus Y bar, and their product. I'll calculate the other things on the next page. Xi minus X bar whole square yi minus y bar here. So what is the data? 2, 4, 6, 10, 14. So 2, 4, 6, 8, 10, 12, 14. Y is 5, 9, 12, 15, 18, 21, 25. Okay, just calculate summation xi. What is summation xi?
48.
Calculate it again.
56.
Yeah, it is 56. Summation xi is 56. Summation yi
105.
not 5. Now I have to calculate x bar and y bar. So what will be that?
Sum of yi is 105. I think
Yes,
you are
yes,
writing
just a
108.
minute. So just tell me the x bar and y bar. So what is x bar? So there are 1, 2, 3, 4, 5, 6, 7 observation. 56 is the sum. So x bar will be 8. And y bar will be, this is
15.
15. Now xi minus x bar. So x bar was 8. So 2 minus 8, it will be minus,
Minus 6.
it will be
mi-
minus 4.
Minus 2. 0. 2. 4. 6.
And y bar is 15. So 5 minus 15, it will be minus 10.
Minus 10. Minus 6.
Minus 6.
Minus 3.
Minus 3. 0,
0.
3.
3. 6. 10.
Okay, then product. So it will be 60.
24. 6. 0. 6. 24. 60.
Okay, if I sum it, so what will be the sum?
4. 90. 180.
180 will be the sum. Now I have to find out the square. So it will be 6. So it will be 36. Here, here it is 4. So it will be 60. Here it is 2. So it will be 4. Then 0. Same comes. So 4, 60, 36. Okay. Now yi minus y bar is 10. So it will be 100. 6, it will be 36. And 3, so it will be 9. And again it is repeated 9, 36, 100. So what will be the sum?
Xi minus x bar whole square is 112.
And yi minus y bar whole square will be
290.
290. So we have the terms like sxy. We have sxy to be 180, sxx to be 112, and syy to be 200. Okay. Now we have to calculate what? First of all, let us calculate the beta 1 hat. So beta 1 hat will be Sxy divided by Sxx. So that is 180 divided by 112. So what is it?
1.61.
1.61. Okay. Now, now I have to calculate MSRES. Okay. So MSRES. So that is nothing but SSRES divided by n minus 2. So SSRES is, so here SSRES is SYY minus beta 1 hat square into SXX divided by n minus 2. So what is n here? 7. 7 minus 2 is 5. So it will be 5. And SYY is 290. So it is 290 minus beta 1 hat square. So beta 1 hat is 1.61. So it's a square. SXX is 112. Okay. So what will be this? MSRES
Minus 0.32.
minus 0.32.
Yes.
Okay. So let me check. It is 290 minus 1.61 square. 1.61 square. So it is 0.32 minus 0.32 divided by 5 also, no? So 0.32 is coming out to be this difference.
Only numerator value.
Yeah, it is only the numerator value.
Minus 0.06.
Yeah. So it will be minus 0.0. Okay. So it is minus 0.06. Fine. Now we'll find out uh, the value of t. So it is beta 1 hat. So beta 1 hat is 1.61. So 1.61 divided by square root of MSRES, that is minus. So MSRES is minus of. Oh, it should not be minus actually. How can it be minus? Okay, so here, what is the difference actually? Here you have taken this value 180 divided by 112 to be 1.61. So don't take it 1.61, just take it as it is, like 1.607. Because if it is 1.61, then this value is becoming greater and you cannot have this MSRES to be negative.
Okay, madam. Okay.
Okay, so just take it as 1.607 only.
Then we take better up to 4 decimal places.
Up to 3 decimal places take, because do not round off, just
Okay.
take 1.607. Okay, so it will be different, because in the square root it will not be negative, and so So what it will be 1.607 multiplied by 112. So it is square. It is 289.234 divided by 5. So this minus 290. It is 0.765 divided by 5. It is 0.153. So this will be the value 0.153. Just take the values till 3 decimal places. Okay, so this is 0.153. Now I can just plug it in here. 0.153 divided by SXX. So SXX is 112. Okay. Here also write 1.607 only. Okay. So what will be till 3 decimal places, just like 1.607, if it is coming, just don't round off, just write 1.607. Okay. Till 3 decimal places, just write till 3 decimal places. Now this 0.153 divided by 112, it is 0.0013, and square root of 0.0013, 0.607 divided by 0.036. What is it?
43.7478,479.
So it is this is coming out to be, mine is coming out to be 44.638. So there may be a difference, a little difference between the your calculation, my calculation, because there are a difference in the decimal points. However, if we compare this with the value from the table, then if you write like in place of 44, if you write like 43, 42, or even 45, then there is no difference because the value is very less for it. This value is very much bigger from the value from the table. So my value is coming out to be this, and if there are different values you are getting, then also it's fine. If there is a little difference, then it is fine. Is it fine? Okay. So this is the value we are getting for this statistic. Okay. Now what I have to calculate, I have to calculate the t value, the value of t. So first of all, t alpha by 2. So here we have 5% level of significance, means alpha is 0.05. Okay. So alpha is 0.05. Since 5% level of significance we want. Okay, so T alpha by 2 will be T 0.025. And what is the degrees of freedom? N is 7 here. So N minus 2 will be 5. So at 5 degrees of freedom we have to calculate. So I also have this T table. So this T table at alpha value 0.025, the degrees of freedom is 5. So the degrees of freedom is 5 or 7, 5, yeah. And the alpha value is 0.025. Just see the value. So it is
2.571.
okay. So this is 2.571. So we can see that here the value is coming out very high. So it is very high. So T is, no doubt, T is greater than T alpha by 2 comma n minus 2. Okay. So which implies we reject H naught. So if we reject H naught means, what does it mean? We reject H naught means
It's a
that
zero.
means 0 is rejected. Means what is accepted at beta 1 is not 0. Means there
Zero.
is a linear association. So this implies there is a linear linear association between the variables. Okay. Now there is a linear association, so that we can fit a linear or I can say a line to the data. Okay. So now if we fit this line, so we want to calculate the residual mean square. Now what is residual mean square? Residual mean square is this MSRES, that is SSRES divided by n minus 2. So this is MSRES is the residual mean square, which we have already calculated. That came out to be 0.153. We have to take one more page. Just give me a minute. So in the next question, it is asked to calculate the residual. So this residual mean square. So that is nothing but MSRES. Okay. So this we have to calculate. So this we have already calculated basically. So this MSRES will be, this is nothing but SSRES divided by n minus 2, which we have already calculated here. That is 0.153. This is 0.153. Okay. Now in the last part, what is given? That calculate the estimates of variance of least square estimators of regression parameters. So the regression parameters is beta naught and beta 1. Okay. And beta naught hat and beta 1 hat are the estimators of it. Okay. I want to calculate the estimates of variance of these parameters. So basically we know that variance of, so we have beta naught hat and beta 1 hat. So variance of beta naught hat and variance of beta 1 hat. So variance of beta naught hat was what? So in the lecture we have covered that variance of beta naught hat was sigma square 1 by n plus x bar square divided by s x x. So this was the variance of beta naught hat, and variance of beta 1 hat was sigma square by s x x. So this was discussed in the class. Okay. Now in here sigma square we do not know. Okay, so we cannot exactly find out the value of the variances because sigma square is not known. In place, what we can find out? We can find out the estimates of these variances. How can we find out? We know that this MSRES is an unbiased estimator of sigma square. So in place of sigma square, we can plug in the MSRES and we can find out the estimate of variance of beta naught hat. Okay, so the estimate of variance of beta naught hat is, so that quantity will be MSRES. So basically we'll replace the value of the sigma square by MSRES, and other things will be as it is, x bar square divided by SXX. Okay, so that will be the estimator for the variance of beta naught hat. Okay, and similarly the estimate of the variance of beta 1 hat will be MSRES divided by SXX. Now we know the values, we know MSRES, we know x bar square, we know SXX, we know n, we know everything. Now we can find out the estimate. So what will be the estimate? So this is 0.153, n is 7, so it is 1 by 7, plus what is x bar? So x bar was 64, no, not 8, so it will be 64. SXX is, so SXX is 112. It is 112. Okay, and variance of beta 1 hat, so it is MSRES is, that is 0.153, and SSX is 112. Just calculate it, tell me that what will be the value of this variance and what will be the value of this variance.
Variance hat of beta naught hat is 0.1092.
This one, beta naught hat.
Yes, yes. 0.1092.
1092.
Yes.
Okay. 1.366. It is a variance of which variance you are talking about?
This one is beta 1 hat is 0.0013. 0.0013. Beta 1 hat
0.00.
0.13.
But 1.366, someone is answering 1.3. Let me calculate it. How can it be 0.13 divided by. Yeah, this is correct. So, 1.366 is not correct. 0.0013 is correct because the numerator is very small and denominator is large, so quantity will be very small. 1.36 is it cannot be. I'm not getting what are you saying. If you are saying that 1.366 into 10 to the power minus 3, okay, then it is a different thing. Okay, okay, fine. So it will be 0.0013, or you can write it in the form of 10 to the power also. That is also fine. And this is so. Is there any doubt in this? In finding out the estimate of the variance of the estimators?
Madam, can you explain that degree of freedom, madam? Here also, mean square residual, you are using n minus 2 degree of freedom. Why it is n minus 2? What about other residuals, degree of freedom?
Okay, fine. Let me explain it. Just take a blank page. So basically, the idea of the degrees of freedom is uh, how many variables are there which we can choose by our choice. Okay, and how many variables are there which are chosen under some constraint. Okay, so the variables which are in our hand, the number of variables, that will be the degrees of freedom. Okay, so this is the like very kind of a vague idea about the degrees of freedom. Okay, so just let me explain it for this case. Just give me a minute. Okay, so here if I write SSRES, okay, so SSRES, here it is written like summation of yi minus yi hat whole square. Okay, or I can say it is written like summation of ei.
Yeah.
Now this now from the constraints, like when we differentiated equated to 0, we had two equations. Summation of ei is 0, okay, and summation of xi is 0. Two equations we had. Okay, so we have two constraints on the values of ei's. So we have I is equals to 1 to n. From these two equations, so we have n minus 2 independent variables, independent in the sense we can choose them by our choice. Okay, but there are two EIs which can be chosen by using these two equations, or these are the two constraints available for the values of the EIs. Because of these two constraints, 2 degrees of freedoms are lost. That's why ultimately we have only choice of n minus 2 EIs. Other two EIs will be chosen using this. So for example, in place of these two constraints, if only we have this one constraint, that summation EI is 0. Okay. Then for example, let us see that E1 is some, let us consider that n is 5. Okay. Now E1 is 2, I can choose. E2 is 3, I can choose. E3 is 4, E4 is 5. This 4 I can choose. But since I have summation ei to be 0, I am restricted to have like 2 plus 3 plus 4 plus 5 plus e5 to be equals to 0. So e5 will be ultimately this negative, this 5, 4, 9, 10, 11, 12, 40, minus 40. So e5 is chosen already. I have only chosen this 4 EIs, and fifth one is chosen by using this constraint. Similarly, so if only one constraint is there, then only we have the 1 degree of freedom is lost. Okay, but in place of one constraint, we have two constraints. Other constraint was summation ai xi is 0. So because of these two constraints, 2 degrees of freedoms are lost. Okay, so that's why now 2 degrees of freedoms are lost. So that's why we are left with n minus 2 degrees of freedom. Is it fine?
Yes, madam. We understood, madam.
Now, what about the? There is a question in assignment also that SST.
N minus
I'm feeling that it is SS total because there is nowhere it is written that it is SS total. I'm not sure about it, but if it is SS total, then SS total is SSRES plus SS, or I can say the SS total. Direct expression for SS total is summation yi minus y bar whole square. Okay, I going from 1 to n. Now here I have yi minus y bar whole square. I have the influence of y bar also. So I know that y bar is some quantity, some constant quantity. For example, 52. I can say. Then due to this y bar, I have a constraint, only one constraint, that y bar is 52. So y1 plus till y, for example, n is 10, y10 is equals to 52. So I can choose 9 of the yi's, but I cannot choose the 10th y10 I cannot choose. So here one constraint is, 1 degrees of freedom is like missing. So because of that, the degrees of freedom of SS total is n minus 1.
clearly understood, madam. Thank you.
Fine. Okay. Now, apart from this, if there is any doubt, then you can ask. Okay. So, this is information. So, if there is any doubt, then you are welcome. Okay. And apart from this, I want to just inform you that the recording for today's session will be uploaded on YouTube. That link I have given you in the chat box, and it is also there present here. If you can, like, you will be able to access this PPT in the Google Drive. So, this is the link. You can, like, just access the recorded lectures there. Apart from this, PPT will be there added in the Google Drive. The link I have pasted in the chat box for Google Drive also. And apart from this, the last day to submit this assignment one is 5th of August, and the next session for week 2 will be on 3rd of August. Okay, the link. So, okay, I will be sharing. Okay, I'll share the link. the link for the channel and the Google Drive link. Okay, so you can access the content from here. Okay, so if there is any doubt, then you can ask, and if there is any feedback, uh, then also you can like share.
Thank you, madam. Your detailed explanations.
Okay. Uh, okay, fine. So if there is no doubt and if there is no kind of a feedback, if you can give your feedback, then I will be like improving in the next sessions. I will be planning the sessions according to that. If there is something, then you may share, or otherwise we'll just end this session for today, and we'll meet on next Monday. Okay, fine. I just hope that in the next session, you all of you just watch the lectures and then come. Then we will be like having more interactive sessions, and so that you people also learn, and I will also be learning with you. Okay. So fine. If there is no more doubts or anything, then we will be ending this session. Thank you all for joining.
Thank you, madam.
Thank you.
Thank you, ma'am.
Thank you.